Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ahmed Hegazy, and in this tutorial video, inshallah, we will discuss how to create this type of team heat exchanger, BEU team heat exchanger. As you can see here in this AutoCAD drawing, we have a bonnet part and the shell part, and inside here we have the tube bundle with appended tube. That's the BEU type heat exchanger. Okay, now let's start modeling of the bonnet with the tube sheet and discuss on the first part of this tutorial how to generate that. Okay, now let's open SEG software, and from new button, let's create a new project and give it a name. And from here, let's select the location of the project and select the module, which is the heat exchanger module. This module will give you the ability to create a tube sheet, expansion joints, many of different items of the heat exchanger. Okay, now let's select the tube sheet, let's select the equipment node from the SEG tree, and as mentioned on the first tutorial for the vertical vessel, you can define the information here. Regarding the position of the equipment, we will leave it as it is, as horizontal, because it's a horizontal exchanger, and we will leave the direction to be left to right. But if you take a look to the general arrangement here, the direction of the this heat exchanger starts from the right direction to the left direction. Okay, in SEG software, if you would like to generate U type of team heat exchanger, we are recommending make it from left to right. So that means you will start generating your equipment from left to right direction instead of right to left direction like this drawing. And in your drawing, you will look from the elevation view from the right view, and we could discuss that. Okay. Now let's keep everything as it is, and from here let's start creating the first element, which is an ellipsoidal head. So it will be right head. Okay, and for the right head, we will select the suitable type for this type of head. Now let's open this one, and if we take a look here, as you can see, it's a half of ellipse. It's not a head with crown and the knuckle radius. As mentioned here in this drawing, it's a half of ellipse. So we will select the same type here, which is ellipsoidal head. It's a half of ellipse, not a head with crown and knuckle radius. So let's select this type and define the inside diameter. As mentioned here in this drawing, it's 740. So it's 740, and the thickness is 18, straight flange 50, and the minimum thickness after forming is 15.5. And here's the head ratio. And here the material, we will keep it as it is, and we will click on save. Now let's add the second element, which is can one. Okay, and from here let's select shell element, and from here, as you can see, if we measure the length of this can from here to the straight flange is 455. So the inside diameter 740, the thickness is 18, and the orientation, if we take a look, the thickness is 18 here, and the orientation for welding line 1 and 3, it's on 300. So it's 300 and 455, and here's the gap, and let's click on save. Now we have another element, which is, let's start creating the assembly, and from here we have this flange, which is heat exchanger flange with a grooved raised face. Okay, it's not with a projected raised face, it's a grooved raised face. Now let's open the SEG again, and as you can see here, we have the first bonnet, and here in your drawing, you will use the right view to add the elevation view for this heat exchanger. Now let's add the designed flange. So from here, let's select designed flange and name it as F1. From here, select this flange. If you take a look to the image on the right hand side, the first type was integral welded neck with a raised face. As you can see, this raised face is a projected raised face, but actually we need a grooved raised face, which is the second type of the designed flange. Kindly take a look to the image on the right hand side, and from here let's define the dimensions of this flange. So the inside diameter is 740, and the end thickness of this one, which is the same thickness of the shell, which is 18 millimeters, and the neck thickness is 24. So we can take a look to this view here. So the end thickness is 10 millimeters, 18 millimeters, and the neck thickness is 24. Okay, and here's the neck length as per this drawing is 28. So it's 28, and the flange outside diameter is 950, and the flange thickness is 114. Okay, and the raised face thickness is 7 millimeters, and the raised face outside diameter is 793, and for the bolt circle diameter is 880, and the bolt hole diameter is 33 millimeters, and the number of bolts there is 36. And now let's save this flange, and let's check the flip option after creating this flange to check if the direction of the flange is correct or not. Okay. Now this flange will be generated, the direction of the flange in a correct way. So as you can see here, we have this flange direction is okay. Now let's add a pass partition, a gasket with a pass partition. So from here, let's select element, and from here, let's select gasket with pass partition and give it a name as G1. And from here, let's select the number of pass partitions. We have 2 passes, so we have a part here on the middle. So let's define the gasket inside diameter is 750. So let's check the drawing here. We have that value, which is the inside diameter of the gasket, and here the gasket thickness. It's as per this drawing, it's 5 millimeters. So we will define it as 5 millimeters, and the gasket width is 20 millimeters, which is the inside diameter, and here we have the outside diameter. The difference is 40 millimeters, so the divided by 2, so it will be 20 millimeters in each side. And here the gasket TB thickness, which is the thickness at the middle here, is 10 millimeters, and here the fillet as per this drawing is 10 millimeters, so we will make this value as 10, and the orientation is 0. And now let's click on save. Now let's add another part, which is the tube sheet. So from here, let's add a tube sheet. So select this item, which is tube sheet, and click add. And from here, let's select the type of the tube sheet. It's extended as a flange. So from here, let's select the second type, which is tube sheet gasketed with shell and channel, extended as a flange. And from here, let's define the outside diameter of this tube sheet. It's 950. And if we come back to this drawing until it's opening, let's define the dimensions. The left inside diameter is 737. Okay, and from the same thing here, it's 737. And for the left face, which is T1, okay, the T1 equals 7 millimeters. Okay, so here we have that value, which is 737, and here that face is 7 millimeters, so it's 7 millimeters and 7 millimeters, and the thickness, which is the thickness at the end here, which is that thickness at the top, which is equal 118 minus 16 and 14, so it will be here the thickness will be 89, and here for the left face raised face diameter, it's 790, sorry, and for the raised face thickness is 8 millimeters and 8 millimeters, and here the bolt circle diameter is 880 millimeters, and for the bolt hole diameter is 33, and the number of bolts is 36. And now the number of passes, let's activate that one and make it with 2 passes, and here define the pass partition, and the fillet will be make it 15, and keep the other dimensions as they are, and from here click on save. Now as you can see here, we defined the dimensions, the main dimensions of this tube sheet, and from the tube bundle we will generate the arrangement of tubes. So from here, let's make an editing on this form and define the shell inside diameter, and the shell thickness is 18, and the clearance, let's make it 10 millimeters, and here the tube outside diameter. So if we take a look to this drawing here, so the tube outside diameter is 19.05 with thickness 2.11. So from here, let's define the tube diameter. Okay, and here the tube clearance, and for here the beach will be 25.5. So if we come back here and check, this detail is 25.4. So let's define the spacing, and here the clearance. And for the top clearance, if we take a look from here, if we measure the value from here to there, for example, here we have, let's say, 110 millimeters around that value. So let's make it to be like that at top and at the bottom. Okay, and for the pass partition, we have two passes, and here the vertical pass lane will equal. So if we come back to the drawing here and check the vertical pass lane, so that value will be 9.58. So let's define 0.58, and the same for the vertical and horizontal pass lane here, and make a symmetrical distribution for holes. And here for the tie rod hole, it will be 12. The tie rod diameter will be 12, and the tie rod hole diameter will be like that. And for we haven't a ceiling rod, so we can keep everything as it is and make all positions with symmetric. So for here for the tie rod position, we can make the depths. So if we take a look here for the depths of the tie rod is with 20 millimeters depth. So we can define this as 20 millimeters depth, and the end will be like that. And for the size will be 12. And for the ceiling rod, we can keep it as it is because we don't have a ceiling rod. And here for the tube layout, as you can see, you can make a selection between a straight hole or a hole with a chamfered end. And now if we come back again to this form and click generate tubes, as you can see here, we can get arrangement for tubes like that. But actually, if we take a look to the tube arrangement, it's 90 degrees. So let's select the square with a 90-degree arrangement, and from here select the big point to be at the center and redraw the arrangement again. Now the vertical bus lane value, we need to redefine it and measure it in a correct way. So let's measure the value from the center here to the center there. It's 25.6. So we need to define this value as 25.6 and 25.6 and draw again. Here we have the modified orientation for this one, and let's take a look for the arrangement of the tubes. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 rows. So here let's check that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need to check the that arrangement again. So maybe something not correct in the arrangement. So we need to decrease this value. So let's make it 55 and 55. Something maybe not correct on the scale of this drawing. So let's check the scale. If we measure that value, the diameter of this hole, it's okay. The scale is not correct because here the diameter is 28.58, and here actually the whole diameter is like that. So I think we need here, so let's check the number of rows again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so let's recalculate that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need to increase this value a little bit. 65 and increase the clearance and recreate the drawing again. So let's increase the clearance again and recalculate. Okay, now we have this arrangement. Let's calculate the number of rows: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 rows by that way. Okay, and let's come back to this arrangement again. As you can see here, if we take a look to that view, we have here 4 equal rows, but here we have 3 rows only. So we need to remove one hole from here, or we can use the that OTL instead of the Visel inside the diameter and clearance, so we can directly use that value, which is 327, for example, and make the clearance equal 0 and draw that again. Okay, the tube sheet clearance. So I think we need to redefine that and generate that. And now let's calculate the number of holes per row. Add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And here, if we take a look, it's 26. So I think we need to increase the number to decrease that value. So let's make it 15 and draw. One, two, three, 5, 6, 7. Okay, so as you can see, we make the number of the first row is 28 holes. Okay, so here for the first 3 rows, we have the same number, which is 28, and for the next one, we have 24 holes. And if we take a look here, after 1, 2, 3, 4, 5, 6, so the 7 hole converted to a tie rod. So on the that row, 1, 2, 3, 4, 5, 6, 7. So this one will be a tie rod. As you can see, we converted to a tie rod, and so those rows will be with 3 holes, and for the other for the top one, it will be minus hole. So it will be that one is correct. And now let's remove this hole, and from here remove this one, remove this one, and remove that one. So as you can see here, we removed the top hole from here, which is the hole exists on that area. Okay, and for the second 2 rows, they are the same, so that one and that one is okay. And for the other one is not include a tie rod or a ceiling rod, but here we have removed a hole after 1 to on the 7 vertical row. So same here, we will remove this one. So the same we will do it on the other side. And here on the same row, we will remove this one and remove this one from that. Okay, now let's go to the tube passes and calculate the number of holes. So in the top side, we have 264, and on the bottom side, it's 264. So 264 by 2, so that's the total number of holes is 528. So if we come back here and calculate or check the number of holes, it's 528 holes. It's the same arrangement of the tubes. Now let's export those information which we generate to SEG. So from here, let's export the information and close this form. Now let's add some attachments like tubes, diodes, and baffles for this tube bundle. Now let's read the tube. Okay, and from here, let's select appended tube and define the length. So if we come back to the model here, as I figured, we have 3 different lengths for the tube, but in SEG software, we can define only one length for the tube. So we will select the greater one. So from here, let's define this value. And here the thickness of the tube, and here the offset, which is the offset from the end, which is that value. So we can measure it from here to there. It's 3 millimeters, and it's clear here in this detail. And click on save. Now let's add the tie rod. And for the tie rod, let's define the tie rod length. So from here, let's check this view. So here the tie rod length is 4893. And for the start thread length, which is that length, it's as per this drawing is 60. Okay, and for the nut offset, it's 40 millimeters, and for the thread at the end is 30. Okay, and the tie rod penetration is 20 millimeters, and the nut size is 12. Okay, and that's the nut size. And let's click on save. Okay, and now let's run the add the baffles. So from here, let's add the baffle 1 or baffle A. Okay, and for the baffle A, we will select the segmental baffle, and from here the inside diameter of the can and the baffle height. So if we take a look to the baffle here, that's the cut, and per the definition here, we need the height. So from this drawing, we can calculate the required height by that equation. So that's the inside diameter divided by 2 to get the value from center here to the inside surface of the vessel. And now let's add the that value, which is that value. So that will be the H value. So we can add it right here. And here the spacing between baffles. So if we check that the spacing equals 800 millimeters. So for the typical, it's 800. So it's 800, and the thickness is 8 millimeters, and the clearance will be 2.4. So how to calculate the clearance? Here we have the outside diameter, and here we have the inside diameter of the vessel, negative or minus 735.2. So that's the total clearance divided by 2. So that will be the clearance in a single side. So we will define this value, and the location for the first baffle will be measured from that face. So from here to there, to the center line. So it will be 782. So we will increase above this value, we will increase the facing thickness here. So the location will be 782, and the orientation will be 190 degrees because the cut, because the cut at the bottom. And here we don't have the vent, and the number required of the baffles is 5. Now let's add another baffle, which is baffle B, and we will make it looks like baffle A. Okay, so here. Okay, so from here let's define the height, spacing, and here the thickness. So the location of the first baffle from type B, we will increase here 400 millimeters. So the location will be 1182, and the orientation will be at 0, and for the vent, that's the vent hole, and here the quantity is 5. Now let's add the last baffle, which is baffle C. Okay, and click on add. And for the baffle C, it's an end baffle, so it's a complete baffle. And from here, let's define the inside diameter, and the cut will be equal 0 and 0, and the thickness will be 16 millimeters, and the clearance will be 2.4, and the location as per this drawing, we can measure it from here to there. Okay, so it's 4,832, so the location will be 4,832, and here the no orientation and no spacing, and the vertical vent. I think we need to check if we have a vertical vent or not. No, we have a bottom vent only, so we can make the orientation 180, so the vent will be like that, and no chamfer and no required quantities. Now let's create the assembly. So the first part will be generated, which is the gasketed pass partition, which is that one. After that, the tube sheet, and finally the attachments for this tube sheet, like bended tube, the first bended tube, the tie rod, and the 3 baffles. Okay, here as you can see, we generate the baffles and the tie rods, and I think we may need to increase the nut spacing a little bit, so we can measure that value. So we can inspect and measure the distance between this nut from that surface to that surface and make it 33. Okay, so return back and make a modification here on the tie rod and make the nut offset is 33, and click on save. Now let's update the assembly to update the nut offset. We need to decrease this value a little bit more, so we can measure the distance from here to the face down there, so we can select the suitable face, which is that face. We need 11 millimeters to decrease 11 millimeters from here, so it will be 22, and on the assembly to update the nut. Like that. So we need to decrease 6 millimeters. So the nut offset will be from here, so be 8. Okay, now it's adjusted. Now to make the pattern of the tubes, before creating the pattern, I would like to notify for something. Here, as you can see, the tubes is for the first row is crossed. Here in SEG, this option is not an option, so we will generate it as a tube directly from here to there. Okay, from here to there, not from here to there. Okay, so now let's come back here, and for the tube sheet, we will open the tube sheet tooling, and from here, let's click on Start Hauling to start generating the tube pattern arrangement and tube sheet hauling. This process may take several minutes to be generated, so I will keep the machine running this. After that, on the second tutorial, inshallah, we will complete the main equipment items, and we will generate some attachments. Okay, here finally we generate the whole pattern for all elements like tubes, baffles. So if we open the tube bundle, tube sheet, for example, you will find here the tube sheet, including the thyroid holes, as you can see here. Okay, like that. And for the baffles, let's close this. And for the baffles, so let's collapse all children. And for the baffles, here let's open the baffle 1. And here that's the first baffle. And the second baffle, which is baffle B. Okay, here the baffle B with the vent. And finally the baffle C, which is the end baffle. It's like that. And as you can see here, there is one of the tube rows. It's shifted a little bit. That's because the API on the Autodesk Inventor 22 and 21 needs an update. So how to solve this? It's very easy. Now let's go to inside this pattern. Okay, and from here you will find here a driven sketch pattern. All what we need to do, just open this pattern and click OK. Nothing else. So as you can see, it's adjusted automatically. Sometimes if you faced this issue, just open the part and double click on the pattern and it will be adjusted in one time. Here, as you can see, we have the tube bundle assembly. Okay, it will be like that. And on the next part of the tutorial, inshallah, we will discuss how to generate the remaining items for the BEU heat exchanger, and on the next parts we will discuss how to add the attachments like nozzles and another nozzle attached to another nozzle. See you on the next part of this tutorial. Thank you for your time. Assalamu alaikum wa rahmatullah. In this part of the tutorial video, that's the second bar, we will complete the main elements of the heat exchanger. On the first part, we generate this bonnet and the tube sheet with the bended tubes and baffles with the tires. Now we will generate the this gasket, which is between the second flange and the tube sheet. After that, generate the we have 3 shell cans, okay, and 1 bonnet. Okay, now let's go to SEG, and from here let's add another tube sheet after this, add a gasket after the tube sheet. So we have a gasket before the tube sheet and we need another gasket after this tube sheet. So let's select the vessel, and from here select a gasket without any pass partitions, so and give it a name G2. And from here let's select the second gasket and define the dimensions of this gasket. So the gasket inside diameter is 750 and the thickness is 5 millimeters and the width is 20 millimeters. And let's add another flange. Looks like flange 1, but we have some little changes. So if we come here and check the dimensions, the thickness of this flange and the thickness of this flange, we will find some little bit of changes. So let's add another flange, which is flange 2, and we will make it looks like flange 1, but we will make some little changes, like changing the thickness of the flange to be 119. So the thickness will be like that, and the end thickness of this flange will be 14 instead of 18 in this flange, so it will be 14. So the end thickness will be 14, and this flange will be flipped. And let's click on save. Now let's add another can, which is can 1, can 2, sorry. Okay, and click on add, and from here we select can 2 and select the type to be shell, and here the inside diameter 740, and the thickness will be 14, and the longitudinal building line orientation will be 60 degrees as per this drawing at 60 degrees, and the length of this can will be, let's measure this line from here to there, it's 2 meters, so the length will be 2 meters, and click save. Now let's add another can, which is can 3. Can 3, it will be looks like can 2, okay, but the length and the longitudinal building line orientation we will change it. So let's measure can 2. So from here let's measure that line from here to there, it's 1051, so the length will be 1051, and let's check the longitudinal building line orientation. So it's not appear on that side, so we could make it 135 degrees like that, and click save. And now let's add can 4, and let's make it looks like can 2, and click add. Now let's modify the length of that can, so let's measure the distance from here to the seam line. It's 2 meters, so it will be 2 meters and the same thickness with the same longitudinal building line orientation. And let's add the last cap. So from here let's add a left head, and let's make it looks like the right head, but we will make some changes based on the model here. So the minimum thickness after forming is 13, and the thickness is nominal thickness is 16. So let's change this value to be 16 and that one to be 13, and make this head as a flipped head. Now let's run the assembly to generate those items. So here we have the gasket. After that, the second flange, first can on the shell side, the second can, and finally the third can. The last part is the second ellipsoidal head. Okay, now that's the 3D model for the main elements of the static set changer. And if we take a half section, longitudinal half section, and take a look to the gaskets here, as you can see, here we have the gaskets connection between the first flange and the second flange. Now let's add some stud bolts to this model. So from here let's add F1, F2 stud. Okay, and from here let's make it an ISO nut and select the size to be 30 millimeters, and the stud length should be greater than the distance from here to there. So if we measure that value, it's 334, so the spacing will be 334, and let's make the total length is 400 millimeters, and click on save. Now let's click on start assembly to start generating the stud bolts for both of those flanges. Okay, and we need to take a copy from that and move it on this flange. Sorry, so let's paste this one, and from here let's delete this stud bolt, and edit the name of that one. Click rename and start generating the stud bolt. So the stud bolt should be on the first flange. Like that. Okay. Now let's add the bus partition inside this bonnet. So from here, let's select the right head, and from elements, you will find the front bus partition. So let's add a bus partition. And click on add. And from here, let's select this bus partition, and you can select the number of paths based on that. And let's select 2 paths. And here the thickness of the bus partition, it's 14. And let's check that on the drawing. So from here, let's check the thickness, it's 14, okay. And the end thickness is 10 millimeters. And the right extended extension, which is the distance from, let's measure the distance from here, which is the seam line between the head and can, up to the raised face, that value, which is 590, be like that. And the chamfer, we can make it as 20. So let's measure it if we have another value. So we can measure it directly from here to there, or we can measure it like that. It's 20, so it's 20 millimeters. And here the whole diameter and the orientation, we will keep it 0. And now let's run the assembly to start generating the bus partition for this ellipsoidal head. As you can see here, we have this bus partition and it's located here to the facing of the gasket. And now let's add a nozzle to the tube, bundle. Sorry, to the bonnet. We have nozzle N01, and if we take a look to nozzle N01, it's a tube side inlet. So we can take a copy from that name as a service. And from here, let's add N01. Okay. And from here, it's a nozzle from pipe, and the size is 6 inches, schedule 160, and keep the location as it is right now. And let's check the other values. Okay, it's with a rebad with 14 width and 16 thickness. So it's rebad with 14 and 16 thickness. And the location, we can measure the location from here. So the location measured from the seam line of the can. So we will measure it from here to there. It's 227. So the location will be 227, and it's in orientation 0. Now let's click on save. And from here, let's define the build. Let's make it 10 and 10 right now. And for the projection, we will need to add a flange first. So from here, let's add N01 flange. Okay, and from here, let's select this nozzle, and from here, select the nozzle type to be a weld neck raised face according to RSME B16.5. Select the rating and the size. Here, the schedule, and click on save. Now, when you come back to the nozzle and open the projection tab, if we check the projection here, it's 750. So we need to define this value as 750 and click on calculate. Now that's the projection of the pipe. When you click on save, the value automatically will be generated here. Now let's start the assembly. Start generating the this nozzle. Now let's remove the cross the section, the half section, and here we have this nozzle right now. Now let's add another nozzle connected to this nozzle. As you can see here in this model, we have another nozzle which is A04 connected to this nozzle. So how to add a nozzle connected to another nozzle? Now we need to add a connection point at the end of this flange. So from here, let's add a can, and let's name it as N01 connection point, and click on save. And from here, let's select this connection point, and go down here and select connection point for a nozzle as a pipe and give it the same properties of the nozzle information like the size and scalable, and click on save. That's a not real nozzle with a projection with a length equals 0, but it has the same properties of the nozzle in 01. But this type is a parent element, so you can add another nozzles to this one. So from here, let's add A04. Okay, and from here, let's go to the nozzle table and check what is A04. It's a vent nozzle. Sorry, it's a vent nozzle. Let's delete this dimension. It's a vent nozzle, 2 inches with a schedule 160. So let's come here. It's 2 inches, 160, and the name of this nozzle is a vent. Okay, and now let's click on save. And for the weld, let's make it 8 millimeters. No rebads, and the location we can measure it from the drawing. So the location from the facing of this flange to the center of this nozzle, it's 230. So from here, the location will be negative 230 because it's not on the positive direction. It's not on that direction. It's on the negative direction. So we will add a negative value here and click save. Regarding the projection, let's first add a flange for this one, which is A04 flange. Okay, and from here, let's select weld neck raised face flange, rating 600, and the size is 2 inches with the schedule 160. And now let's come back to the nozzle A04, and from the projection, let's check the projection of this nozzle. If we take a look to the projection from here to the facing of the flange, it's 300. So let's add the projection as 300 and click OK. And now let's create the assembly of the nozzle which is connected to nozzle N01. Okay, we will need to change the orientation of this nozzle a little bit. Okay, it's on 0 degree, so we need to change the orientation with 90 degrees and click on run the assembly. Sorry, we need to make it 270 because it's on that side. So from here, 270. Okay, and click on save. Now let's take a copy from nozzle N01 with all attachments and make nozzle N02. So from here, let's take a copy and click on paste. And now we have a new nozzle, this nozzle. So it's N02 and click rename. And from here, let's rename the flange N02 flange. Click rename, and for the connection point N02 connection point and click on rename, and for nozzle N4 it's nozzle A01 not E04, so it will be A01 and click on save, and for the flange it will be A01 flange and let's click on save, and from here let's come back and change the orientation to be 90 degrees and click on save. Now let's run the assembly to update the orientation of nozzle A04 and create nozzle N02 and A01. Okay, I forget to change the orientation of nozzle N02 to 190 degrees. I kept it as 0, so it will be located. If you take a look here, it's that's N02. It's located on the same location of nozzle N01. So we will come back to nozzle N02 and change the orientation to be 190 degrees and run the assembly to update the orientation of nozzle N02. Okay, as you can see, now it's updated and the location of the other nozzles updated too. Okay, now let's add another nozzles to the this can. So from here, let's add N04. So if we let's check that one, it's 10 inches. So let's take a copy from the name of this nozzle, which is N04, and select can 1. And from here, let's add N04 and click on add. And this N04 is 10 inches. nozzle with the scalable 160 and no with a rebad 65 with 16 millimeters, 65 with 16 millimeters, scalable 160. Okay, and for the location, so let's check the location from here, and the location measured from the parent element start node, so it will be measured from here to there, so it's 352, and here's the name of this nozzle, and let's click save. And for the welding details, let's make 10 millimeters with 10 millimeters, and now let's add a flange to this nozzle, so it's N04 flange. Okay, and from here let's select the type, the rating, let's check the rating if it's 600, yes, it's all flanges with 600 scalable, and the size is 10 inches with 160, and let's click on save. Now to modify the projection, let's select the nozzle again, and from here let's check the projection for this nozzle. It's 640, so from here it's 640 and click on calculate. Now that's the projection of this nozzle. Okay, now let's check the nozzle N03. I think it's has the same properties with another name, so we could take a copy from this name another time. So from here, let's take a copy like that and make paste. If you would like to add it directly to CAN 3, you can do that. So it's located in CAN 3, so you can select the last CAN, which is CAN 4, and click on paste and give it another name, which is N03. Okay, and click save. And from here, it's N03 flange, and click save. And when you come back to this nozzle, we need to change the orientation 190 degrees. And one more thing, which is the name of this nozzle. So let's take a copy from the name of this nozzle and paste it here and click on save. We need to change the location of this nozzle based on the parent element. So the start of this parent element starts from here. So the location of the nozzle from here to there. So it's 1401, 1401, and click on save. Now let's click on start assembly to start generating the nozzles. Okay, now we have those the inlet and outlet nozzle. And if we come back to the 3D model here, we have nozzle A02 and nozzle A03. Both of them has a cover. Okay, and by the way, this nozzle has a cover, so we could add for one of them add a cover like a gasket. So A04 gasket. Okay, and this gasket will be 600 with size 2, and click on save. Now let's add a blind, so it's A04 blind, and from here let's select the type, rating, and size and make it flipped and click on save. Okay, and when you click on start assembly, we will add a gasket to this flange with a blind. It will be like that. And if you would like to add a stud bolt to this one, we can do that. So from here, let's measure the nut spacing, so we can take a copy from this, and from the survey we can get the bolt sizing for 2 inches with the schedule 600, so it will be here. It's 5 by 8 and the length is 110. So from here let's add a stud, so 804 stud. from here, let's select this 5 by 8, and here that's the length, and here's the not spacing. And now let's click on save, and when you click on run, just simply we will generate a stud bolt for this blind. Okay, by the same way you can make take a copy from the gasket and the blind and make a paste for the other nozzle down here, which is A01, which is that one. Here we have this stud bolts for the top nozzle, which is that one. By the same way, you can take a copy from the gasket from top to bottom, and let's try that. So we can take a copy from here, copy, and make a paste like that, and from here, sorry, okay, let's modify the name of this one, A01 gasket, and save, and take a copy from the blind with the stud bolt and make paste here. Okay, so that's the blind, so it's A01 blind, click save, and the same for the stud bolt, and click rename. And now let's add another nozzles. So let's come back here. We have a nozzle which is yes, it's A02. So if you come back here for A02, it's drain 2 inches, and here that's the size and rating. Okay, it's with a blind, so we can take a copy from all of this nozzle, okay, which is A04, and take a copy from here because it's located on a shell, and make a paste there, okay, and check the name, which is A02. Okay, so from here let's rename this nozzle to be A02, that's the name of the nozzle, and let's rename all the other elements A02 flange, and for the gasket it will be A02 gasket. Be sure that you add the right names, okay, don't make repeated names. And finally here's the stud bolt A02, okay, and click on save. One more thing we need to modify here, which is the projection and the orientation. Here the orientation on 190 degrees, and the projection is 640. So when you come here, it's 180 degrees, and for the projection it's 640. When you click like that, you will get the projection of the pipe, and it will be reflected here on this form. Now let's take a copy. We have another nozzle which is looks like A02, which is A03. It's located on the one more thing is the location. I forget to define the location. It's the same location of nozzle A04. So if we open A04 here, so it will we will get this location. We will need to reflect it here. Okay, and click on save. Now let's take a copy from A02 and go to the last can and make paste. And here we have A03. So we will rename this nozzle as A03. Okay, and rename all the other items A03 flange, and for the gasket A03 gasket, and for the blind A03 blind, A03 stud bolt. Okay, and now let's come back to nozzle A03 to change the location and orientation. So it has the same orientation, the orientation will be 0, and it has the same location of nozzle N3. So let's open nozzle N3 and take the location and paste it here, and click on save. Okay, now let's run the assembly to generate the other nozzles. And first we will generate the gasket for nozzle A01 with blind. After that, the stud bolts for that one. Here we have the final model for the main elements with nozzles. Assalamu alaikum warahmatullahi wabarakatuh. In this part of the tutorial video, the third part, we will discuss how to generate the support saddles and how to add lifting lugs on this bonnet head and another lifting lugs for this body flange, and how to make some modifications like on the flange hooling, like that on the tube sheet. We have some holes with some different details for the hauling, and how to make a chamfer on this flange. So we will discuss some of those points during this part, inshallah. Now let's start by creating the fixed saddle. So from here, let's select CAN tool, and from elements, let's add fixed saddle. And from the fixed saddle, we will select the type of the saddle web plate case to be the web at the right side. So let's define the contact angle. So from the saddle detail drawing, the contact angle is 120, and the web thickness is 12 millimeters, and the height is 750. 12 millimeters, and here we have a contact angle, and here's the width, and here's the thickness is 12, and here's the the fillet weld. Okay, here's the fillet weld is 50, and now the base plate is 730 by 100 millimeters with thickness 14. And for the hole diameter, let's check the drawing. It's 2 holes with 28 millimeters, okay, and with offset 50, and on the other side, the hole offset is should be, I think the value is not correct. The hole here, hole spacing is, I think it's 100 millimeter, not 50. So the scale of this view is not correct. Okay, so let's come back here and define the hole diameter like that, and from the offset from the shorter this is 100, and the offset from the long edge is 65. Okay, and the location, let's check the location. So the location is from the center of the base plate to the that edge is 747, and the orientation will be like that. And the wear plate offset, if we take a look to the saddle detail, so the wear plate offset is 25. Okay, and for the sides, it's straight sides. So if we take a look to this image here, the sides here with 90 degrees. So if we measure the angle from here to there, it's 90 degrees. So the sides is straight sides. So we will keep this checkbox selected. And for the web offset, it's at 0. And for the outer ribs, we have ribs 100 millimeter and 100 millimeter. And for the thickness, it's 14 millimeters. And we have intermediate ribs. And the spacing here as per this drawing is 150, and the thickness of this one, so it's it's 213 plus 14, it's 244, so 244. And now let's click on save. Okay, and now let's add another saddle. So we can take we will need to add another saddle with a left side, so it's a sliding saddle. Okay, it will not be right, it will be a left web. So we will select the second one here and define the projection, the thickness, and for the wear plate it will be like that, 730, it's 100, and base plate 14, and the long radius will be like that, and the slot length. So let's check the slot length. Here, as you can see, the slot is along to the end, so we will need to make that cut manual. So the half of the slot is 7.5, so the slot length is 15. So this slot will be 15 millimeters. And from here, the location, we can measure it from this drawing. So let's come back here and measure the location from this point to the center here. It's 896, so it's 896. Here's the orientation, and it's 25. And for the width offset, it's 0. And here's the top width of the saddle. Top width of the saddle is 100 at the top and the bottom, so it will be 100, and the thickness is 14. And from here we have intermediate with the spacing as we did on the previous saddle, 244. One more thing, if you would like to make a rendering for elements during creation, you'll open the setting tab and make a render review for the childs and click save. And now when you click on run, simply the saddle assembly will be generated like that. Now we did both of the left and right saddle assembled to the vessel like that. Okay, now let's make a modification on the base plate here. So let's open this sliding saddle, and inside the base plate, let's make a modification on that one and make a cut. So from here, or we can open this part separately, so we can make the modification easily here. And from here we can project the hole like that, and we could make a cut like that, convert this line to be a construction line. The same thing, we can do it on the other side and make this point connected to here, convert this line to a construction line, and all those lines equal, and give them round value, let's say 100, and make an extrude cut. Okay, so let's select extrude cut through all and in both sides, and now we have this cut on this base plate. So the cut will be like that. Let's open the sketch and hide this sketch here. Let's delete this sketch and click save. Now we have the modification on this saddle by that way. Now we discuss that we will make some modification on those flanges and the tube sheet, but before that let's add a lifting lug here on this bonnet. So here we have a lifting lug here. So when you select the top head, and from elements you will find here different types of lifting lugs. So we can try lifting lug type 2. Okay, and if we select this type, you can figure that you can add it on an ellipsoidal head. So based on the image here on the bottom, that's in case if you have a shell, and that's in case if you have a head. Now let's define the dimensions. So the distance C, so we will need to go here, and it's 125, so it's 125, and offset D, which is the whole offset, it's 125, but I think it's not to scale. I think it's not to scale, but let's draw it 125, and the thickness of this lifting lug, it's 12 millimeters, and the hole is 30 and radius 35, so it's 12, and the F is 35 and hole diameter is 30. Okay, and the offset, okay, so the offset is 260, and the orientation at 0 degree, and we have only one no wear plate or no cooler plate. So let's run the assembly. So here we have this lifting lug on the this head. Now let's add a lifting lug to the body flange F1. So let's select F1 from here, and from elements, let's add a lifting lug. So from here, let's add lug A. Okay. And from here, let's define the bottom width 125, the thickness is 12, and the bin hole diameter is 30, and the radius is 35. Hole offset L is 125. The location will be on the lid of this one, so we can measure the distance from here to there. It's 85, so it's 85, and the orientation 45 degrees. No more data, so we can take a copy from this, okay, and make paste, okay, and name it as lug B. Okay, so it will be lug B, and rename, and from here the orientation we can make it 315, and run the assembly to start generating the lifting lugs on the body flange. Okay, now we have the lifting lug here on the body flange with the same dimensions. Okay, now let's check how to, as we discuss during that, how I would like to remember. Okay, with the modification on the flanges. Here we have some flanges here, and we would like to make a modification like adding a chamfer or adding some details for holing here. Okay, so if you would like to make a modification, for example, on this flange, you will just open this flange, and here for the facing you can make a chamfer at this end, and here let's check the chamfer value. It's 6 millimeters. So from here we can make this chamfer with 6 millimeters, and click save. From here close this one, and the same thing we can do it here, and adding a chamfer at this edge with 6 millimeters. Okay, and now let's modify the some of holes here. So let's open, as you can see here, we add the chamfer at the end of the flanges. Now let's open this tube sheet, and for example, let's select some of those holes to make some modifications. So we can create a sketch here, and let's select some of those holes, like that one, for example, that one, and that one, for example. And now let's make an offset for this hole, like that, and let's select the yellow holes and make them construction only, and select the black holes and make them black circles, give them equal order, and give them the same diameter. And now you can make extrude for that with extrude cut. Okay, extrude cut. So we can make extrude cut and give that extrude a value for that, so we can check the value of this cut. It's not mentioned here, so we can assume it, let's say 15 millimeters. So it's extrude cut with value with 15 millimeters, for example, to be, or make it less. Let's make it 25. Okay, so as you can see here, we make some of those holes with some different definition. Okay, and now we have the 3D model of this heat exchanger. As mentioned on the previous tutorial video for the vertical vessel, you can add some attachments like grounding lugs here, or a nameplate, or anything else. And you can add stiffening grips. Let's check some of that. Here for this nozzle, for example, that nozzle, we would like to add a stiffening grip. So from here, let's select CAN 4. Okay, and from elements, let's add nozzle support rib. So it will be A03 support rib. Okay, and actually we will need to give it the same location and same orientation. So when we move to this one, you will need to select the suitable configuration for your shape. Okay, so that's the configurations that we would like to do, and here the outside diameter of the pipe, and here the rib width and the rib thickness. And let's give it the same location, the same orientation, and let's measure the angle of this one. It's 23, so the angle is 23. And for the thickness, let's assume it as 10 millimeters. And for the rib width, so we can measure the width from here. So it's like this, it's 30 millimeters. So the width is 30, and from here the location, orientation, and the rib offset. As you can see, it's the offset from the end of the pipe. So we need to get the projection of the pipe first. So let's save this and come back to the pipe itself, and I get the projection from here. Copy and come there and paste the projection. And now you can add the offset. So the offset, if we measure it from here to there, it's 15. So the offset is 15. And now if you would like to add some other ribs, like adding another rib on the other side, you can do the same thing, 23, and that's the width. If you would like to add another rib on the other side, the same for that. So we can save that, and you can run the simply to add stiffening grips for this nozzle. Okay. Okay, I will make a modification on the second rib to make it this rib. Okay, and click on save and make the offset equals the offset here. So it will be 15, 15, 15, and click on save. Now let's run the simply to modify the ribs offset. Okay, now we have those ribs. One more thing I would modify it, make it on the make it on the other side. And click on to add another rib on the other side, like that. Okay, now by that way you can add stiffening grips for the nozzle and control the number of ribs that you would like to add. Okay, now let's add a nameplate. So if we take a look to this one, the nameplate located on the first can. Okay, and the location from the seam line here. So from this point to the center line of the nameplate, it's 1050. So let's select can 1. From here select elements and let's add a nameplate. So from external, let's add a nameplate. Okay, and select the suitable type for your case. We could select this type and define that value. Keep it as it is, and from here that's the thickness, and the projection we could make it like that. And here's the location, the orientation 170, the thickness of this one. Let's add a okay, and from here let's make the offset from all sides, and here the height will be 180. And now let's click on save and run the assembly.